All right, continuing on, we are moving on to chapter 13, section 3, which is dealing with tangent and secant lines within a circle. So we're looking still at a circle, and we're looking at some of the chords that can be used for this circle. So first thing is what a tangent and a secant is. So in circles, a tangent is a line that's coplanar on that circle, but it only touches that circle at one point and one point only, which basically means that if you have your circle and you have a line that goes through, it only touches at one point. So it doesn't actually go through the circle, it kind of nicks it and then keeps going. Okay, so that would be your tangent line. A secant line is a line that's coplanar, so it's on the same plane as the circle, but it touches the circle at 2 points. Okay, so something that goes through the circle. Okay, so a line that goes through a circle would be considered a secant. Okay, if it touches that 1 point, it would be a tangent line. Okay, but it has to go all the way through. So let's say we have these two lines here. Okay, we'll label this one as I don't know, D, and this one as E. Okay, so now looking at these, take a second. Which one is the tangent line? Okay, so then which one would be the secant line? Right, and hopefully you got these right. The E line would be considered the tangent line because as you see it's going on the outside and it only touches at 1 point, while D would be our secant line because it touches at both. Okay, so that's our secant and our tangents. Okay, so a line is tangent to a circle at point P whenever the line is perpendicular to the circle or to the radius of that circle. So if we have a circle and we have a line that we think might be a tangent, okay, so that line down there we think might be a tangent. One way to know for sure is to check the radius. And if the radius crosses it perpendicularly, then we have a tangent. Okay, if it doesn't cross it perpendicular, then it's not a tangent. Okay, so that's what that one's saying, is that if you have a tangent line of a circle, the radius will always cross it at 90 degrees or touch it and they create a 90-degree angle. Okay, so if we have one application for this is that let's say we have this circle and we have our radius. Okay, and 1 second. We have our tangent right here. Okay, and then we have this length right here. Okay, now if I wanted to find the length of, let's say, the radius here, and I know that this length has to be 13 and this length is 12. Okay, what am I going to do to find the radius, or that red line that I've drawn? Okay, well, if you look at this, we end up making a nice little right triangle. So we have a little right triangle, so we can use the Pythagorean theorem to help us find it. We have 13 squared is equal to 12 squared plus x squared. Okay, plus x squared. And then we'd go through and we'd solve it using the Pythagorean theorem. So 13 squared is 169, 12 squared is 144. We'd end up subtracting those, getting us x squared is equal to 25, which tells us that that radius must be 5. Okay, so we can use that to help us find missing lengths of it. So whenever you have a tangent and a radius, you can create a nice little right triangle to help you find missing parts of it. Okay, so tangent segments from a point to a circle are always congruent. So with this one is that if we have a circle, okay, and we've drawn two tangent lines, okay, they intersect outside the circle somewhere, but they're two tangent lines. What we know for sure is that these must be congruent in length. So the distance from your tangent point of tangency is what it's called, to the intersection point outside of it, that distance must be the same. Okay, It has to be the same. So if I took a, let's say another point, so if I took tangents and crossed them there, this length and this length would have to be the same. Okay, they have to be equal. And that's always true with a circle if you draw two tangents. So if I have a circle and a point right here, and I draw a few tangent lines, and if this is 6, this length down here, x, must be, that's right, it must also be 6. Okay. All right, so that's the end of this section, section 3. Here's your homework posted on here, and make sure you get it done.